So good morning to all. Welcome this webinar on K-Rail Silverline Project. I would now request Mr. George Joseph, the Secretariat Member of Breakthrough Science Society, to start this session. Thank you. Over to you, Dr. George.
Good morning, everybody. Welcome to all. I request Sri Kumar Case, the President of Breakthrough Science Society, Ernakulam chapter, to give a introduction and welcome to Sri Alok Kumar Verma.
Okay, sir. Thank you, Joseph, sir. I am very happy that we could conduct this program with one of the well-known experts in the field, Alok Kumar Verma, sir. So, Breakthrough Science Society is conducting a series of webinars regarding this K-Rail. We have already conducted a webinar on last Sunday regarding the main speaker was Dr. C.P. Rajendran, and now we have got a very one of the well-known experts in the country about the technical aspects of high-speed railway, Mr. Alok. So all of you know that he was a chief engineer in the railway department, and now he is a well-known figure in Kerala regarding all the discussions regarding K-Rail. He is a member and he is a participant, and we also have had opportunity to have a lot of meetings regarding this K-Rail. And as you know, he was an alumni of IIT Kharagpur and IIT Kanpur. In 93-96, he was working at Research Design and Standard Organization (RDSO) of Indian Railway, and carried out studies for raising speed of the railway to 160 to 200 km per hour. In 1995, he visited Swedish Railway and spent a month studying modernization of track and bridges for high speed. In 2006 and 7, he attended a 9-month program at Indian Institute of Public Administration, and there also he wrote a dissertation regarding the 200-250 km per hour railway, high-speed railway. And he also visited a number of foreign countries like China, Australia, and Hong Kong, Singapore, etc. In 2008, he developed a new alignment methodology with the sleeper gradient for the Kashmir Rail Link project. And you know, he retired from Indian Railways in 2016. And after that, he joined Sistra MBA, and he was a consultant and a lead figure in the this study regarding the K-Rail. Preliminary feasibility report was prepared by under him. And such a well-known figure, we got him today as an expert for our presentation. And when we contacted him, he readily agreed for this webinar. And I welcome Alok Kumar Verma sir to this webinar. And I welcome Dr. P.S. Babu, George Joseph sir, then Professor P.N. Thangachan, Dr. P.P. Rajivan, and all other members of our Breakthrough Science Society Kerala chapter. And I also welcome all the participants of this webinar. Thank you. Over to George Joseph, sir.
So we'll start. Welcome to you, sir. Please start.
Thank you. Thank you very much. And good morning to all the distinguished members of this society who are present here, and all others who are connected to us on the YouTube and on this channel to take part in this discussion. It's really heartening to see so much of interest being generated about this project in Kerala particularly since July this year. And a lot of people are taking keen interest, trying to understand what this project is all about, whether it will benefit the state, what are its shortcomings, its disadvantages, what are the problems if this line is built, which is going to be extremely costly, maybe definitely more than 1 lakh crore, but it could touch even 1 lakh 40,000, 60,000 crore also, because of several issues. So it's very heartening to see that people have really woken up and they are taking notice of what is being proposed and planned for the state of Kerala, which is in dire need of better transportation. Because Kerala has a topography, very challenging topography, which has, you have the region of mid highlands, on the western part on the eastern part of this line, your NH66, you can say, NH66 and your existing railway line on the eastern side, on the foothills, on the foot of Western Ghats, that region of mid highlands, it is full of, it is like if you see it, if you fly over this terrain from Trivandrum to Kasaragod, you will see in the month of, in the rainy months, in the month of monsoon, maybe July, August, September, and you will see it's like a cluster of islands, floating in a sea of water. The islands are the high ground where people live, and the water is all where, you have paddy fields and backwaters and lowlands, which get filled up with rainwater in these months of rains. So this is a very unique terrain, and that is why you have, a population, urban population is scattered all over the state. It is not like this, that urban population is in a few very big cities, like Mumbai, Ahmedabad. You have got 5 big cities, Mumbai, Ahmedabad, then Vadodara, then Surat, and then maybe Borivali and that area. So most of the population, urban population, lives in a few cities, 4, 5, 6 big cities, you can call them really big cities. And then there are small cities which are comparatively very small, but it is not so in Kerala. In Kerala, you have got, you don't have very big cities, but there are hundreds and hundreds of cities and towns where population is quite significant, 50,000 and above is not a small population. And you have, I think, 40, 50 cities, which are having population more than 50,000. Even though the cities like Ernakulam and Thiruvananthapuram, their population is just around 1 million. So they are small, but the population is scattered into a number of cities. So it poses a lot of this population distribution, the scattering of urban population and the topography. It is a huge challenge for making a railway line, and in fact even making highways. As you would be knowing, NH66 is your main highway going north south. So a lot of 4-laning was planned, and some of it was executed, some of it could not be executed because of land and other problems. Now government has recently announced even 6 laning of the highway, but it seems very difficult. I don't see any much possibility in achieving 6 laning of NH66, at least up to from Thiruvananthapuram to Kozhikode. In this area, 6 laning is going to be a very, very difficult job. So there is a big issue in Kerala, to have a better system of transportation, which will reduce the journey time, because highways and railway lines, they are roughly 30% slower than the average for the country. So there is an urgent need for doing something. But is K-Rail the solution? That we will look into in our discussion. So I must start in a frank manner. I will say that the entire planning has been very badly managed. Very, very badly managed. It will be hard to find any other project of this size and this magnitude, and then for a breakthrough speed of 200 km per hour. In India, we don't have anything more than 160 right now. 160 is also in some small patches, on maybe 2-3 lines. Otherwise, we are mostly 130 to 140. And that is the maximum speed. Average speed is, you can say, is half of that. Most of our trains, important trains, they average about 70 to 90, 70 to 80. Some are able to do better, but that is the average speed, 60 to 80 for Rajdhani trains, Shatabdi trains, and all that. So, why this has happened? Let me start with the chronology of the planning of K-Rail. I will call it instant planning. Instant, like something like instant coffee, like you don't have to do the whole thing of preparing coffee, which can take 15 to 20 minutes or maybe longer. So you just take a pouch or maybe a cup of, a spoonful of instant coffee and mix it in water and milk, and your coffee is ready. So the planning which has been practiced on this project, and in fact, this is not just this project, this is happening in most projects on Indian Railway, because of certain systemic failures, that planning is not getting the attention that it deserves, and due care is not being taken up. Kashmir Railing project is a very, very good example, and a glaring example for the whole country to see what is happening, when you don't plan properly. Just briefly about the Kashmir Railing project, the DPR of Kashmir Railing project was approved in 1999. The project was sanctioned by Cabinet Committee of Economic Affairs of the central government in end of 99. Then it took almost 3 years. The work started on 2002. So this time of about more than 2 years was good enough to do a thorough geological and other ground studies, to really come up with a very good alignment. Okay, but nothing happened. Because people, once they make a mistake, they are not, and they tell the government of India that this is the alignment, and these are the places where it will be touching, and this will be the cost. So then they think that if I go back to the Prime Minister and the government and tell him or tell her that no, we are changing the alignment, the cost will be so much, then they are not inclined to do that. So a mistake which has been made, that mistake persists. There is a audio recording. If you don't believe me, there is an audio recording. A brainstorming session was held after I submitted a proposal for changing the alignment of Kashmir Railing project. Northern Railway held a sort of a brainstorming session, which was attended by many experts, top authorities of top officials of KRCL, I mean the Konkan Railway, because they are involved in that project, IRCON, and a lot of consultants were present there. A lot of retired senior officers were also present there. And what does the senior most and most respected person, what does he say? It is on record. He says, do you want to go back to the Prime Minister and tell him that we were wrong? This is what he said, it is on record. So this sums up the attitude of people at the top. Once they make a mistake, they are not inclined to accept it. They will do anything but accept that mistake. So a lot of mistakes have been made on this project, and people are not willing to accept. But let me tell you for record, and these are facts, so nobody can dispute. If anybody insists, I have got the documents also on my computer, and I can show them to you. So how it went wrong from day one, how it went wrong. KRDCL submitted a proposal for a broad gauge line from Thiruvananthapuram to Kasaragod, a broad gauge line which will carry high-speed trains in the daytime, and in the night time it will carry long-distance trains, normal trains. So it was going to be a fully integrated broad gauge line. That was the proposal, original proposal of Railway Board of Kerala government. But there itself things it was horribly bad report. Why? They said this will be a elevated corridor. I mean, it will be completely on viaduct from one end at Thiruvananthapuram to the other end at Kasaragod. It will be fully elevated. So that there are many advantages of an elevated line in Kerala, because land acquisition will be reduced, disturbance to the people will be very less. So it appeared to be a very, very attractive idea. In fact, when I was in Thiruvananthapuram for preparing the first feasibility report, wherever I went, people would ask me, is it really going to be elevated? People were even surprised also that this is going to be a completely elevated line. So how this idea of an elevated line came? Because somebody told that we should make an elevated line, and people followed those instructions, without questioning whether an elevated line is feasible or not feasible at all. They should have done a simple survey, Okay, and it won't take more than 3 or 4 days to tell whether a elevated corridor is possible or not. But these people, they didn't try to do even that. They didn't try to spend even 1 week to find out whether a elevated corridor is feasible or not. So this proposal goes to Railway Board. Now, as I said, it is a culture, it is not just that there is problem in this project. This problem is everywhere. In Railway Board also, nobody examines it, this fabulous idea, rather fantastic idea of a thoroughly elevated corridor, end to end, and costing only about, that time the cost was estimated to be only about 45,000 crores. So nobody really saw it, and they said, okay, go ahead. We agree with you for a third and fourth line, which will be elevated for 200 km/h. So you can now start preparing the feasibility report and DPR. So that is when they engaged, this consultant, whom they call Paris-based or French consultant, but it's not really that. It is really they are connected with that French company, but all the work is being done in India by Indians. There is hardly any involvement of France or French people in this. So they engaged them. They recruited a team, a team of experts, different experts, somebody in rolling stock, somebody in signaling, somebody in this and this. Then they approached me, whether I could come over for some time as a consultant and help in preparing this preliminary feasibility report. So I agreed. I said, okay, I'll come. I'll complete, I will do the preliminary, I take this responsibility that I will give you a preliminary feasibility report. So as I started my work, of course, I went all over Kerala from north to south, every place, saw the condition of roads and the whole thing, everything I saw. And then I concluded immediately that elevated corridor is not possible. And then I also said that why you want to make it a standalone line on standard gauge? Because as I told you, their original proposal was also for a broad gauge line, which will be fully integrated with the Indian Railway network and carry both high-speed trains and also normal trains. So I said that this is not a good, this standard gauge standalone is very, very disadvantageous. Nobody does it like this. No country in the world has gone for, a standalone line here, then another standalone line. There is a proposal from Rajkot to Ahmedabad. Nobody does anything like this. Railways work only when they are a part of network. Then you can make the best use of your railway line, of your investment. Because, you know, if you make it on a standard gauge, what happens is that there is it is disconnected. It is not connected to the Indian Railway network. So your trains cannot go outside this one line. You know. Suppose you want to send a train to Coimbatore. It's not possible. Mangalore or Kanyakumari or maybe to Madurai. You can't do it, you know, because it is disconnected. It is standalone. Similarly, if you want to say, I want to run my Rajdhani, my all mail express train, because I have got now a new line. I have put in more than 1 lakh crore rupees of money on this. So why should I not run my important trains, existing important trains also on this normal trains? Then all those trains will benefit, because those trains are today constrained to run at only about 100 kilometer maximum speed because of the too many curves are there. There's a lot of problem of stability because ground is weak, settlement of foundations and all these, you know, a lot of speed restrictions are there. So if I can carry all my important trains on the new line, then journey time of all these trains will also reduce. For example, your Rajdhani Express, which today takes about 9.5 hours from Trivandrum to Kasaragod, would complete the journey in just about 6 hours, you know. So that's a massive gain. So similarly, all mail express train will reduce their journey time by about 3 to 4 hours, 5 hours. So, but if you make it a standalone line on a standard gauge, then all these benefits simply evaporate. You will just have those daytime intercity trains running up and down, which are where fare is so high, you know, it is almost like a second AC fare, AC sleeper, second AC sleeper. So how many people can afford it? You know, I think not more than 10%, you know, considering that Kerala has more prosperity, per capita income is little higher, you know, is more than average in Kerala. So I mean, that one mistake, you know, of adopting a standard gauge has sort of, you know, is a big handicap for this project. Now, then what happens is Railway Board says, okay, you go ahead, engage, and then, but anyway, they don't listen. I mean, then these people, KRDCL, say, no, we have got the approval of Railway Board for a standard gauge. So I told them, okay, please show me, where is the approval? They couldn't show me because Railway Board has not approved a standard gauge for this line. It has simply said, okay, we have examined your proposal, we support it. And that proposal was for a broad gauge line. So approval is for a broad gauge line. It is not for a standard gauge line. Whether you call it a separate line or a standalone line, it is a broad gauge line, because your proposal was for a separate broad gauge line, separate in the sense that it will not be running along the existing line, it will be little away from it. So anyway, then we deliberated within Sistra, you know, because I was engaged by Sistra as a consultant. So we had an internal discussion. Now what to do? We have almost done all the work, assuming taking it as standard gauge, but now we find that Railway Board's approval is not there. So after a lot of discussion, we decided, okay, we will recommend that you adopt broad gauge and make it an integrated line, so that it will benefit in many ways. Your cost will reduce, your ridership will improve, will multiply by 2 times or 3 times, and the requirement of land and dislocation of people will be drastically cut down, you know, because if you have broad gauge, then you will be using the existing stations. And it is for stations that you require maximum amount of land, you know, that is prime land where people are living. So we recommended that you go for broad gauge. Anyway, KRDCL decided, no, we will go for standard gauge. Rightfully, they should have referred the matter to Railway Board and sought a decision. But no, they said no. They sort of instructed this consultant Sistra that you prepare for standard gauge only. Now what happens is, you know, a preliminary feasibility report has been prepared. Now you have to prepare the final feasibility report, which is the most important document. This final feasibility report takes about, for a project of this size, it will not take less than 2 to 3 years, because you have to do all sorts of ground studies, geological, geotechnical, hydrological. Then you have to do ridership survey. You have to do ecological, environmental impact study. You have to do social impact study. There is so much of groundwork to be done. It's a huge amount of work to be done to make a feasibility report for a project of this size, But they did it in just 45 days. How did they do it? They didn't do any ground survey, nothing. They used Google Earth topographic data, which is very, very wrong. You should never do anything like this. They prepared some alignment. They picked up certain locations for stations at various places. And sort of a big thick volume of was prepared, which didn't have any ground survey, no ground data. It is I would call it it's a fictitious report, It's a fictitious report. You can't call it it's an invalid report. But anyway, it goes to Railway Board, and again Railway Board keeps it for 6 months and then approves it, without really seeing that this is in total violation of your own codes and manuals, which say that you have to do this study, this study, this study, this study, and you have to come up with a realistic estimate of cost, a realistic estimate of ridership. They didn't see anything, and the project was approved. So you saw how elevated corridor was proposed, and how now you have a line, which is 80% on ground, in cuttings and embankments and trenches and things like that, So Railway Board gave approval to this feasibility report in the month of December 2019. Okay. Then hurriedly, they prepared DPR. As I said, people don't accept their mistakes, They may commit blunders which may harm the project badly, but they will never accept their mistake. This is how our government organizations work. Our bureaucracy and our institutions mostly work, whereas they should not work. First of all, there should be proper planning. You should prepare a plan which is realistic, which is feasible. And if you have made any mistake, you should be willing to accept it and make changes. But now you see what they do. For now, DPR is finally out. They were, KRDCL was fighting tooth and nail, and even they were able to even convince the courts, that it's a intellectual property rights violation. So DPR cannot be released. They resisted a lot, but finally, some political leaders, they succeeded in getting the DPR out. Now DPR is out, and we have seen the DPR. I have examined it thoroughly. They did not do any meaningful ground survey even then, even for DPR. No geological survey, no hydrological survey, a very rough kind of environmental impact study, no social impact study. So they did not. I mean, it was a time, okay, you made some mistake in feasibility report, you submitted it in a hurry, or then this was a time to do all the ground studies properly, but they didn't do it. They have done geotechnical investigation. They say we have collected one borehole. You dig a hole in the ground, and then you take out the material and examine it, at every 5 kilometers. But that is meaningless, That is meaningless, because in fact, if you just take one borehole, it can give you a very misleading picture also. This thing of borehole is only one thing you have to do. You need a continuous mapping of the ground, so that you know where, say between Kollam and Kottayam. Now, I want to know where the ground is good, where I can make viaduct, where I can have a high embankment, and where it is weak. So I will have to dig, I will have to make viaduct on deep foundations. So I want to know the complete situation from Kollam to Kottayam. I should have the full picture. That is called mapping, geological and geotechnical mapping of the entire stretch. Now that is missing totally. They have just, put 800, I think it's about 900 pages of this geotechnical report, which does not even have a proper index, which does not have any page numbering. It has just been put there. Now it is showing borehole locations, but it does not show where is the alignment. I mean, this sample which you have picked up, where it is it on the alignment or is it away? How far away? 5 meters, 10 meters, or 200 meters? So this information is not given where this borehole is located. But then from the DPR, I collected the coordinates and I checked it for 20 locations. I have done it, in last. In fact, I have written part 1 and part 2 of my article on DPR, and part 3 will be coming out next week, perhaps by Tuesday. So I will put all this information in part 3 of my article. So now what I find that out of these 20 locations, on 16 locations, the sample point is about 100 meter to 1 kilometer away from the line. Now that doesn't make any sense, I mean, it's very bad, it's wrong, should not do it. In the remaining 4 locations, it is say about 50 meters or nearby, but it is on a road or near a road, not on the alignment. You see, road is where, your traffic is moving. So over, say, 50 years, 30 years, depending on how old is the road, the ground gets compacted. Near the roads, the ground is compacted. You also have buildings and all that, so ground is compacted. So it is well known that you should not take sample near the road. You should take it where your line is going to come. So all these things are there. So lot of fudging and fabrication is there in the DPR, which I will cover in my part 3, which I will not discuss here, because if I discuss here, it will take a lot of time. So I will address the other important issues. I will focus on that. Now, you see, we have seen how it happened, from the initial proposal of 2018 to 2019. In 45 days, they prepared the feasibility report, and then without doing any proper ground surveys, they prepared the DPR also. Now why this happens, Now let's look into it a little bit, You see, transportation business is very dynamic among all the industries, It is, maybe except the computers and software industries, it is a very, very dynamic industry where technological developments are taking place at a very fast pace, and what happens in France or Japan will impact you, because you get your technology from there, from countries in Western Europe and Japan and North America. So what is happening on those countries, the systems which are being developed in those countries, you are going to now use them one day. Okay, like, this bullet train from Japan, you want to transpose it and make it between Mumbai and Ahmedabad. So just see let's see what was the transportation situation in 1950. 1950 or till the end of Second World War, railway was the dominant mode of transportation. You had few small airplanes, only few people could travel by air. Similarly, very few people could own, except North America and Western Europe. Rest of the world, very few people could afford to buy a car. Then how rapidly things have changed. By 1969, you had jumbo jet. So cost of flying. I mean, over the last 40 years, 50 years, the cost of flying is falling down steadily. More and more people can now afford to travel by air. If not in India, then at least in Western Europe and America, people have almost everybody, 90%, 95% people can afford to regularly travel by air in those countries. Though in India, it is still hardly 5% people can afford to travel regularly by air. Then similarly, road transportation has undergone a sea change. The condition of roads has improved a great deal. Now every middle class family has got a motorized vehicle, whether it's a motorcycle or it is a scooter or it is a car. Everybody has got a personal vehicle. Those things have changed in every respect. In railways also, things have exploded, You see, I will tell you that India was keeping abreast with the world, with what was happening in the world till about 1970. We introduced our first Rajdhani train around, I think, 1966 or so. Then second Rajdhani was introduced between Delhi and Mumbai. So till about 1975, India was keeping pace with the developments in rail transportation all over the world. China was way behind us, Our railway system was much more advanced than that. Then, I will say something somewhere around, 1995 or so, railway almost went to sleep, I mean, railway, I mean railway board. They were perhaps not aware that the world of transportation is changing, that highways are being built in the country, families can own their own cars, more and more people are able to travel by air. You are going to face very, very tough competition. You have to upgrade your lines. Why is it that that railway line in Kerala is still running at 90 to 100 kmph for last 60 years? Why was nothing done to improve the speed on that line, Thiruvananthapuram to Kasaragod? Why was nothing done? Because everywhere in the world, including China, they have upgraded their existing lines to 160 to 200 km per hour. This is perfectly feasible even in the worst of terrains. Even in Kerala, you can raise the speed on this line to about 160. Not 160 everywhere. Some places it will be 140. Maybe between Trivandrum to Kollam, it will be 140, then 160, and then beyond Kozhikode, even 200 is possible on the existing line also. So it was possible, but nothing was done. The same thing happened all over the country. Our speed of Rajdhani was 130 kmph 50 years ago, and today also Rajdhani runs at the same speed. No improvement, no change. So why is it so? Because there is a sort of a paralysis within railway. Paralysis means people are not really aware of what's happening. So they approve things like standard gauge. Why do you approve standard gauge? What sense is there? Is there any justification for building a line on standard gauge? When you already have a broad gauge, standard gauge is also categorized as a broad gauge. Okay. In the world, there are 4 or 5 broad gauges. One is the standard gauge. Why is it called standard gauge? Because UK Parliament, Britain's Parliament, they were seeing, it happened I think in around 1860 or 1870, more than 150 years ago. They were finding that different railway companies are using different gauge. So there is no connectivity. So the matter went to the British Parliament and they standardized it, So that is why it is called standard gauge. They said, except for Ireland and maybe some other places, all the lines in United Kingdom will be on this gauge, 4 feet 8.5 inches. So this is why it got the name of standard gauge, because it was made standard by UK Parliament. But there are other broad gauges like the Indian broad gauge, which is an Indian subcontinent. It is in Argentina, in Chile. And then there is the Iberian broad gauge, which is in Spain and Portugal, which is almost same as Indian broad gauge, just very minor difference. The trains which can run on Iberian gauge can also run on Indian broad gauge, as was proven by this company Talgo, which brought their Iberian gauge train and they ran it from Delhi to Mumbai on our track, So it is interchangeable. So practically, the whole Indian subcontinent, Argentina and Chile and your Spain and Portugal, they all have the same gauge. Okay. Then there is the Russian gauge, which is about 5 feet or so. That is in Russia and the neighboring countries, which are earlier part of the Soviet Union. So all these countries, Uzbekistan, Kazakhstan, then Romania, Bulgaria, most of these countries are having Russian broad gauge. So when India already has a broad gauge, why do you need another broad gauge? Because the size of the trains, the size of the coaches, the loading of the load carrying capacity of the wagons, the passenger carrying capacity of the trains is the same. Only thing is the gauge is different. In India, you need broad gauge because India is having a lot of flat terrain with soft soils, alluvial and coastal areas, of India, where most of the population lives, is having alluvial plains, So broad gauge is the right gauge for India because it helps to spread the load over a larger area. Because when the gauge is the clear spacing between the left and the right rail. So our broad gauge is about 18% wider than the standard gauge. So the load is distributed over a larger area, and this is a big advantage for places like Kerala, where we have the problem of soft soil. So what I'm saying is that because of this disconnect, at the top leadership of Railway Board and Indian Railway, where people are not really keeping abreast with what is happening world over, what is a bullet train and what is a standard gauge, that is how these decisions are taken. Suddenly somebody decides, I call it instant planning, Somebody gets the idea, make it on standard gauge. So make it on standard gauge without really seeing, without doing any comparative study. So this is what people have to understand. There is something is wrong. Something is really missing, which is why such proposals are coming forward. And because most likely the politicians are also not informed properly about the whole thing, what is there inside the DPR, how they have proposed this thing, how they proposed elevated corridor and all those things, So even the political leadership is not convinced, they want to go ahead. They want to go ahead and build this line. So people are, now questioning them also, why you want to go ahead with this? There are these are the. So what I'm saying is that what is happening in Kerala and this public churning of public opinion which is going on is good for the whole country, because I'm sure if this spirit continues, then at least something good will come out of it. This thing about standard gauge should be killed. Nobody should talk about the standard gauge ever. You have to focus and improve your broad gauge because it is cheaper. It has many advantages. Standard gauge is a nonsense and should be given up. Okay. So this issue is very important, and there is a systemic flaw in the whole system of railways decision making, which has to be rectified so that this is not repeated again. Now, you see, you may have heard about this thing, Pune-Nasik. Pune-Nasik, they are building, they have proposed, a broad gauge line. And that proposal has also been given in principle approval. Okay. Now you see Railway Board is approving broad gauge there for 250 kmph. And here in Kerala, your senior officials of KRDCL are shouting from the rooftop that broad gauge cannot carry trains at more than 160 kmph. I mean, how absurd is it, Railway Board has approved Pune-Nasik for 250 km/h on broad gauge. And as I told you, the Iberian gauge, Spanish company, they brought their train. That gauge is same as Indian gauge, and Spain has been running trains at 250 kmph on broad gauge for 20 years. It is one of the most advanced railway system. Then how can MD of KRDCL shout from the rooftop that broad gauge, nothing is possible above 160 kmph? How is it possible? But this is happening. KRDCL keeps on repeating again and again, that 160, nothing above 160 kmph is possible over broad gauge. So such things must stop, So now, as I said, I will be releasing part 3 of my article about DPR, which will contain more details about this, how land survey has not been done. And one thing which I have, told the media also, that it is a roller coaster alignment. This is something which I should tell you why it is a roller coaster alignment. They prepared the alignment on using Google Earth without any ground surveys. Now, when they started making DPR, now they had to somehow, adjust it, how to adjust it. Because it was a fictitious alignment. Now they have to make a real alignment. How to do it? So they ended up having lot of horizontal curves and lot of vertical curves also. I mean, up and down, and horizontal curves. Total length of the line on horizontal curves is more than existing line. It's really worth laughing, I mean, your high-speed line is having a longer length in curves than your existing line, and lot of vertical curves. So what happens is, when you have lot of steep vertical curves and lot of horizontal curves, it is called a roller coaster alignment. It will result into a lot of parasitic and secondary motions in the train, and the train can even derail. Maintenance, operations, everything will be very difficult. You may not be able to run trains at even 120 km/h on this line. And you see another surprising thing. They say our consultant is French-based. I will tell you how France dealt with this problem of roller coaster alignment. When France was making the first line from Paris to Lyons, okay, that is the first high-speed line outside Japan. Japan was the first country to make it in 1956. After that, it was France, Paris to Lyons. So they decided that, I mean, the government at that time, they gave them instructions, order, sort of a mandate, that you have to reduce the cost of the line so that every French man can travel by this. It was, I think, government of Mitterrand, I think the Socialist Party. They said, we want a railway line which every French man can afford. It will not be for the select 5% or 10% rich people. Every French man should be able to travel by these high-speed lines that we are going to make in the next 20 years or so. So these engineers, they worked on it. They found a solution that we will use steep gradients, steep rise and fall, because France has got a undulating terrain, gently undulating terrain. So they came up with this solution that we will use steep gradient, go up and down, so that we don't have to make tunnels and high viaducts, which are very costly. But they immediately realized, which anybody should realize, that if we do that, then we could end up with a roller coaster alignment. So they studied the problem, they found solutions, they limited the number of curves, then they designed the suspension system of the trains also to take up the these parasitic motions in the train. So the whole high-speed railway system of France has been designed to tackle the problem of a roller coaster alignment, because their alignments are also having curves, vertical and horizontal, not so much as they have made in their KRDCL and this company has given in the alignment, but they also have this problem, and they immediately anticipated it, and they have come up with an entire system to deal with this problem. So this roller coaster alignment is a very serious drawback of this thing, and in fact, this is an invalid alignment. This is my assessment. Of course, it will require a lot of simulation studies and other studies, which can be done. If anybody really wants to say, no, I will make a line on this, I will follow the DPR, then okay, then you at least send it to the France or some other country. Let them examine whether this roller coaster effect is there or not, whether it will be safe, for what speed. Have it examined. Now let's see what is the way forward. Or rather, what is the alternative? As I said, that this is the practice everywhere. All developed railway systems, whether it is in Europe or Japan or China, they first upgrade their existing network to 160 to 200. Depending on the kind of terrain, ground conditions, you can raise it to 160 or 200 kmph. So that your cost goes down, requirement of land goes down, you start getting benefit very quickly. For example, you take the example of China. Between 1997 to 2012, in 13 years, China upgraded about 15,000 kilometers of their network, all important lines like Beijing, Shanghai, then line to Xi'an, and Chongqing, Chengdu, Kunming, all these important places, Guangzhou in the south, they were all these trunk routes, they upgraded to 160 to 200 kilometer per hour. And they did it in 6 stages, So the country starts getting benefits, First the speed is raised to 140, then to 160, then to 180, then to 200, and then where possible to 250 also. So the most obvious solution is upgrade the existing line. Now people come up with all kinds of excuses. There are too many curves. You will present the alignment which you have come up with. It has got more length in curves. Curves is not a problem because I have got the full list of curves of this Trivandrum to Kasaragod. There are many curves. Almost 1/3 of the curves are of 1 degree, and 1 degree curves can carry trains up to 190 kmph. There are some curves, which are sharp, which are 3 degrees, 4 degrees, which will have to be straightened, which is not a very big work. In fact, the bigger work is, that because of the poor soil conditions, you will have to improve your embankments. So that work will be required. So I have done a sort of a rough calculation, and my estimate is that by spending 15,000 crores, a total of 15,000 crores, including cost of importing tilting trains. You will need about 5 sets of tilting trains to provide about 15 pair of services, on this line. It will cost about 15,000 crores, and you can do it in 3 to 4 years. Okay, 15,000 crores, 3 to 4 years. You can upgrade the existing line, decongest the existing stations, for which Southern Railway already has a plan, like Ernakulam, they are adding platforms, they are adding some loop lines. So the total cost of decongesting the existing railway stations, the cost of realignment, strengthening of formation, import of tilting trains, everything will cost about 15,000 crores. And you will be able to reduce journey time from Thiruvananthapuram to Kasaragod to just about 5 hours. They are promising 4 hours. You can achieve 5 hours by upgrading the existing line, spending 15,000 crores. The requirement of land will be 10% of what their present require. For the new line, they need about 1,300 hectares, total about 1,500 hectares. you will need just 10% of that for upgrading the existing line. And the good part is that when you realign, you release the old land also, because say you shift your alignment by say 100 meters. So this old alignment is abandoned, say in the 10 kilometers or 5 kilometers, that can be flattened and used for other purposes. So upgradation of the existing line from Trivandrum to Kasaragod is the most sensible option, the cheapest option, and the most convenient option. I am not going to say that Kerala should entirely give up the plan of a new line. No, it need not be given. But you work on it. You will need about 3 to 4 years to really plan for a proper 200 kmph line with a thorough investigation of ground conditions, coming up with examining various alternatives, various possible station locations. You will need about 3 to 5 years to come up with a proper plan for a 200 kmph line in Kerala. And if that line is going to be made on broad gauge, there is no reason why Kerala should bear the cost of that line. Railway board and central government will bear full cost of that line. Upgradation of the existing line also, the whole cost will have to be borne by railway board, because your whole Indian railway network will benefit from it, because you are upgrading the existing line. At the most, board can say, okay, we will give priority to you if you bear say 10% of the cost or 15 or 20%. That's a matter of negotiation. So the big advantage is that it will cost only 15,000 crores. It can be done in 3 to 5 years, 4 years, 3 years. It's a realistic estimate, 3 to 5 years. Maybe maybe half of the line can be upgraded in 3 years, and some places, where ground conditions are bad, that may take 5 years. But you start getting benefit, from the third year onwards. Your journey time starts reducing, say from 9 hours to 7 hours, then to 6 hours, then to 5 hours. And then most important is that most of the costs will have to be borne by the central government, not by the people of Kerala alone. So that a solution is there. But yes, for the long term, you should go for a new line, which again, the cost should be borne by the center, because it will be a broad gauge line integrated with the existing Indian railway network. Kerala may chip in with some cost sharing so that it gets priority. Otherwise, board can say, no, for me, Chennai, Bangalore is more important, or say Hyderabad, Bangalore is more important, or maybe Ahmedabad, Delhi is more important. But if Kerala government says, no, we'll bear some cost also, then you will get priority also. So I think I have covered most of the points. If anybody has any questions, it will be my privilege to answer those questions. Thank you.
Thank you, sir. A few questions have come.
Yeah.
So one question is, can you elaborate what was made against the codes, railway codes in the project? Some example.
Yeah, I'll tell you. You see, there is a engineering code of Indian Railways. Engineering code, okay? This code prescribes the entire process of approving any project for a new line, okay? If you want to propose a new line, then what you have to do? First stage of feasibility study, second stage of feasibility study, and third stage, which is the DPR. In what stage you have to do what? It is all prescribed there. So all the 3 reports which has been prepared by KRDCL, the first report of 2018, which was for a broad gauge line, then the second report, feasibility report, which was prepared in 45 days, and the DPR. All these each of these reports is a total violation, not a small violation. It is a total violation of the codes. You don't prepare any feasibility study or any DPR like this code. It is totally against code. Now I'll give you one example. Code says, I have already discussed, but I'll give you one more example. I have already told you that why geological survey is required, geotechnical survey, hydrological survey, ecological survey, social, all these are written in the code that you have to do all these things which were not done. Another important thing is, it says, when you are giving costing, say you have taken certain cost of the viaduct, okay, per kilometer, unit cost. You have taken certain unit cost of embankment. You have taken certain unit cost of cuttings and tunnels. The code says that you have to collect rates for similar works done in that area or nearby areas in the last 3 to 5 years. So for example, viaducts, viaducts have been made at Kochi for the metro. They are of course for standard gauge and light, their speed is less, their weight is also less, but then you can, from there you can put a factor and come up with this. Then you have got rates in Chennai also and other places. Then for embankment, you have got rates from Southern Railway of at their construction office at Ernakulam. They could have collected rates from Ernakulam construction office. So you have to collect rates, what are the prevailing rates for these works. Say there is something for which rate is not available. Say embankment, you will be making this embankment for 200 kmph, whereas Southern Railway is making embankment only for 100 or 100 kmph. Then there is something called rate analysis. The engineers will sit down. They will collect the rates of material from market. They will they will make an assessment, man hours required of different categories of skilled, non-skilled people, material required and everything. And then they will come up with a realistic estimate of cost. It's called rate analysis. Now this DPR, it does not contain anything. No rate analysis, not a single rate of, not a single accepted rate from nearby areas for similar works. People have just written, viaduct 40 crores, embankment 10 crores. How did you get this figure of 10 crores and 40 crores? No basis. It's all, your sweet will, So it's a total violation of the codes and procedures of Indian Railway, which are very well written in black and white.
Sir, another question.
Yeah.
Is elevated rail or elevated or on viaduct, is it practical for K-Rail?
Yeah, you see, that's a very good question. You see, if you make elevated, first of all, completely elevated is not possible, as I have told you earlier, because the terrain is like this. You can't have it elevated from end to end. There is a problem in elevated also, because then your height of, columns becomes very much, For example, there on this line, they are taking Thrissur. The railway line will go above the existing station. Okay, that viaduct will be almost 20 meter high. I mean, this is what I have estimated from ground level, that it will be 20 meter high viaduct right through the middle of the station. The entire station may have to be dismantled to create space for this line. So making viaduct is also not a solution. First of all, of course, the issue of gauge is there. You have to have broad gauge so that you can use the existing lines. You don't have to do all this, thing of making elevated viaduct to carry the line through the existing station across. Same thing they are doing at At Kozhikode, they are proposing an underground tunnel, which will first go under a river, and then it will pass through the most congested part of Kozhikode, and then the station will be built in a 42 meter wide cavity. So, I mean, these are, and nobody has done, as I said, no proper ground surveys. How are you going to make it? And one thing, I have written in my part 2, part 1 of my article, what is the width of the station at Thrissur? 100 meters. It is more than width of Churchgate station. Churchgate station, which handles so much of daily traffic, so many trains, they want to make station at Thrissur 100 meter wide. Similarly, station at Ernakulam is also 100 meter wide. Station at Kochi-Valley is also 100 meter wide. I mean, I don't know what is the point in making it. These are not big junction stations, These stations are only for this line, which will carry on one down line and one up line, one up line, one down line. You don't need a 100 meter wide station. But this is what they have proposed at Kochi-Valley, at Ernakulam, and at Thrissur. So the point is, and that at Kozhikode, they are proposing a 42 meter wide cavity to create the station. What I'm saying is that you need proper studies, geological, geotechnical, a proper alignment survey after topographic collection of accurate topographic data. And according to me, because I was involved totally in this first report, first feasibility report, the preliminary feasibility report of March, my assessment is that the best solution is low height structures. For Kerala, we need low height structures, viaducts of low height, not more than 6 meters, okay? Embankments, which will be 4 to 5 meters, cuttings. So we have to design our alignment in such a way that we do not need very high viaducts, we do not need very high cuttings, and we do not need high embankments. On the present alignment, which they have proposed, the embankments are 12 to 17 meter high. No, that is almost like a 4-story building, 3 to 4-story building. That is the height of viaduct at some places in the DPR. So what you need is a proper alignment survey to have low height structures, because low height structures will impose less load on the ground so that your ground can take the weight and vibrations which are coming on it. So like I had made this assessment that about if you make it on broad gauge, then about 50% of the line will be on low height viaducts. 20% of the existing line will be used, including all stations, and only remaining 30% will be in embankments and cuttings. So 50% elevated, 20% existing, and remaining 30% will be low height embankments and cuttings. So that kind of alignment is feasible for a new line. And my estimate is that it will cost less than 50,000 crores for a broad gauge line. To make a broad gauge line, it will cost about 50,000 crores, whereas on this alignment, standard gauge line will not cost, even Niti Aayog has said, 1,20,000. My estimate is anywhere between 1,40,000 to 1,60,000. So what you need is, there is no straight answer, but the main thing is that viaduct should not be very high. They should be of low height, and embankment should also be low height, looking into the requirement of topography, the low bearing capacity of the soil, and other factors.
Another question.
Yeah.
When high resolution satellite data are available, why should we go for a ground-based survey? Another subsidiary question is, they are using LIDAR for grounds, I mean, survey, and that is being used for even estimating the land requirements. So is that correct?
Yeah, I'll tell you. You see, for topographic survey, LIDAR survey is sufficient. Okay. You have to just verify it by doing final location survey, which they have not done. Once you have prepared your alignment, you should mark it on the ground and check whether the actual height of structures is same as what is there in your paper alignment on your documents. So as far as topographic survey is concerned, LIDAR survey is adequate, okay, subject to field verification, okay. But for geological conditions, geotechnical conditions, hydrological conditions, there is no method of remote sensing. There are methods of remote sensing which will give you, which are a first stage, okay, first stage to give you a sort of a appreciation of the ground conditions. But then you have to do actual field survey for geological, geotechnical, hydrological conditions. You have to do physical measurements on the ground. So that is why I said, you know, the feasibility report, DPR, takes about 2 to 3 years because you have to do all these surveys, because you have to go to the field, collect samples, carry out the tests in the ground. Like, you know, you may have heard of, you know, this, you know, seismic reflection survey, seismic refraction survey, then ground penetrating radar method, you know, all these methods are available, but you have to go to the field and take measurements. So remote sensing is workable for topographic survey only, subject to verification. But for everything else, remote sensing will do 10% of the work. 90% of the work is actually going to the ground and testing and measuring things.
Sir, another question is, it is said that K-Rail is importing outdated technology, which is 40 years old. Is that true?
No, no, that is not correct. No. You see what is happening is, as I said, you know, transportation business industry is very fast moving. So nowadays, all the locomotives and coaches which are being manufactured, you know, the technology is being constantly upgrading. So it is wrong to say that they will be imported, it is outdated. No, it is not outdated. That is not the problem. The problem is that it is on standard gauge, which is not suitable for India. You make it on broad gauge, you will get the latest technology from all these. You see, what is happening is, you know, with these people, you know, they try to misguide. You see, there are 4 or 5 major manufacturers of trains, locomotives, coaches, wagons, and train sets. You know, one is French, one is German, Japanese, one is in Spain, then one is in US also. So there are 6, 7, 8, you know, big players, you know, and they have developed design which they are adapting for different gauges. If Russia wants something, Uzbekistan wants something, India wants something, or somebody else wants something, they will adapt it to their gauge and give it to you. So there is, you know, in fact, when this bullet train project was being planned, Spain, I mean, the France and Germany, they both offered, you know, that we will give you bullet trains for broad gauge, Indian broad gauge. So as far as technology is concerned, you can get the latest technology for broad gauge, standard gauge, no problem at all. I mean, don't say that I'm going for standard gauge because I will be able to get latest. No, you will get latest technology for your broad gauge also. Yeah.
Sir, another question is whether the proposed high-speed rail from Chennai to Trivandrum is on broad gauge. If yes, is it planned by upgrading the existing lines or through a new line?
You see, there are, I mean, this is, in the last 15 years, so many studies have been done on broad gauge, standard gauge, that anybody will lose track of it. Take the example of Mumbai-Ahmedabad. Original survey was for a 200-kilometer line. Okay. That was a very good proposal. Make it a 200 km per hour line. Then another survey was done for bullet train line on broad gauge. It was done by Sistra, you know, this Sistra, but not this Sistra, but Sistra, which is actually in France. Sistra and some Italian company and some Indian. It was a joint feasibility study. It was for a broad gauge line, broad gauge bullet train line from Mumbai to Ahmedabad. Then these Japanese came into the picture, you know, and they offered a sort of a sweet candy, you know, that we will give you loan, provided you import 30% of the trains and equipment, you give us 30% of the contract, something like this, you know. And I don't know, a railway board fell for it, you know, without really, I have seen that, I have studied the whole thing. Railway board did not carry out any comparative study of making Mumbai-Ahmedabad line on standard gauge vis-a-vis broad gauge. But as I say, no, instant planning. Railway board is the perpetrator of instant planning. They take decisions in a moment, without without any studies, without anything. They take decisions, you know. So this is the result of these decisions, you know, that you know, Rajkot Ahmedabad line 160 km per hour being proposed on standard gauge. Does it make any sense? So let us not talk about this, you know. Let us focus on this thing, that you have to make a 200 km per hour line from Trivandrum to Kasaragod. It should be built on broad gauge, fully integrated, because that was also the original proposal of KRDCL also. All the technologies is available. To make it on standard gauge and or broad gauge, I will not go into that controversy because there is something wrong there. Considerations are something else. Why people are going for standard gauge? Railway board has also not even clarified why they are making Mumbai-Ahmedabad line on standard gauge. They have not answered this question to anybody's satisfaction. So this is standard gauge. This is standard gauge. I will say it is being imposed by these, you know, these vested interests. You know, they want that India should make line on standard gauge and be dependent on them for at least next 20 to 30 years, because it will take 20 years for Indian Railway to adapt standard gauge. You know, it's not so easy. You have to learn everything about it. Standard gauge means an entirely different system. When gauge changes, a lot of things change, you know. You will have to create manufacturing facilities in the country, and you'll have to acquire the capabilities for designing viaduct and embankment, or you will do work like what KRDCL has done, you know. Just do anything. Create a fictitious report, create a fabricated report. This is what is going to happen. So this is why I have said, you know, this is the churning which is going on. Kerala is very important, is very good. It is exposing what these people have done, what KRDCL and Sistra, what they have done is now fully exposed. How they have fussed and fabricated every report, violated every rule. So many important rules of Indian Railway have been violated in preparation of these reports.
One question is, what are tilting trains? In your view, what would be the cost of the proposed Silver Line? Approximate time for completion of this project?
Okay, first let me answer this second part, cost, because I have already dealt. If you are going to make a 200, 250 kmph line from Kasaragod to Trivandrum, on broad gauge, it will cost about 50,000 crore. On standard gauge, it will cost about 1 lakh crore. Okay. On the existing plan, because it is a fabricated plan, it is not supported by any ground survey, anything. This will cost anything, 1 lakh 40 to 1 lakh 60,000. So you have got three options. Go for a broad gauge, 50,000. Go for a properly designed standard gauge, about 1 lakh, and go for the present alignment and spend 1 lakh 40,000, 1 lakh 60,000. So now I will answer that question about tilting trains. Tilting trains are widely used all over the world. In fact, even the Tokyo to Osaka bullet train line, the busiest and high-speed line, it is having tilting mechanism, because this was the first line which was built in 1964. It has been upgraded, but normal trains can run at only 270. So it is using tilting mechanism to run trains at 300 kmph. So tilting mechanism is used all over the world. Italy, Germany, Spain, Sweden, Scandinavia, Finland, to name a few. Even Boston to Washington line is also using tilting trains. So tilting trains, the advantage is that you don't have to make a new line. The existing line can be upgraded, strengthened. Curves, only few curves may require to be straightened. Most of the curves can remain as they are, because it can go even on sharp curves at 20 to 30% higher speed. So tilting train, you see, as I said, first solution is to upgrade the line and then use tilting trains also. But to have higher capacity also, you need a new line. But tilting train is the ideal solution for a place like Kerala. Okay, where you have an existing line which has got enough capacity. Capacity utilization from Thrissur to Kasaragod is just about 50%, 50 to 60% only. And here also it is about 80 to 90%. And all these estimates are very rough. There are many lines in the country which are running at 124%, 130% capacity utilization. So for a situation in Kerala where land is so precious, where time is running out, you want quick results, you want early results rather. So as an interim solution, go for upgrading the existing line and use tilting trains. And for the long term, you should plan a new line. And cost of tilting trains is not very high. If a normal train like Vande Bharat, which runs at 160, it costs something like 80 to 100 crores. A train set for 200 will cost something like 150 crores, 120 to 150 crores, one train of 8 coaches. A tilting train will cost about 20% more. That's all. It's not a very costly thing, because it only has the mechanism to tilt the car body, the body of the coach on the curves. So it's not very costly.
Sir, another question. It seems that embankments have been singled out by some people as a main issue.
Yeah.
Can you elaborate on the impact of embankment in the rain-fed state of Kerala? Is underground structures suitable for Kerala, since predominantly the water table is high, which might increase the cost of construction?
You see, again, I will say why all these voices are being raised. Because the plan has not been made properly with adequate studies. Okay. That is why you are now, DPR is revealing that certain embankments are up to 12. I found one location where it is 17 meter high. Okay. So certainly this is going to be a very big problem. You see, in Kerala, all the water is coming from the eastern side, from the Western Ghats, and it is swiftly flowing into the Arabian Sea in a length of just about 50 to 100 kilometers. So flow is very rapid. And that is why you have these devastating floods, when there are cloud bursts and things like that, 5,000 mm rainfall annual. Then you have these flash floods, So this embankment, on this, as per the K-Rail plan, which is going to be 8 meter, 10 meter, 12 meter, 17 meter high, this is absolutely a big risk, absolutely undesirable. Because what they are saying that we will provide a sort of an opening at every 500 meters. Do you think that opening can stop the flood waters? No, it cannot. When the water comes, it comes like a deluge. It will wash away your embankment. It will destroy your, it's very likely that it will act as a dam, and a critical situation may be reached where the embankment will be washed away. Now, I have heard MD KRDCL saying in a meeting where even Chief Minister was present about 15 days ago. I think there was a meeting somewhere in Trivandrum where CM was present and a lot of top officials were also present. So I read the newspaper. MD KRDCL is saying that this embankment is like the existing embankments. I mean, this kind of misinformation is shocking. On the existing railway line, embankment is hardly 2, 3, 4 meter high, I know this, your existing line very well. They don't have such high embankments, like you are having on K-Rail. So it is very misleading, and it is a deception to claim that it is like the embankments of the existing line. No, I will tell you, the amount of material required for making the embankment and the present line is going to be about 3 times the cost of building a normal line like the existing line. So there is no comparison, absolutely no comparison. These embankments are going to be a very, very big risk. Not only these embankments, but also, they are making a lot of, cut and cover tunnels, they will be digging, at many places, at about 112 places. I have written it in my note also, in part 1 of my article. At 102 or 104 places, they will be digging trenches, about 15 to 20 meter deep. Then they will be creating a shell of the tunnel and then backfilling it, filling it up back. Now, they have not examined whether it is at all possible. How many houses are there nearby? What will, those houses may develop cracks, When you are making such a deep trench, the houses may get damaged, It can affect their drainage during construction. It can have a lot of, you don't do such things, without proper survey. And this is the result of all this, that they will be making these huge trenches, huge embankments, huge cuttings, which are not possible at all. And I think that is why people are sensing it, and people are protesting, because you see, why, when people are protesting so much, why has KRDCL not marked the alignment on the ground? You see, it is called final location survey. DPR without final location is incomplete. In final location survey, you mark the entire alignment. You put pegs on the ground, at every 100 meters or 200 meters, you put a peg, that this is the alignment. So you will know my house is here, so this railway line will go here. Then they will give people the drawings. Okay, here embankment is coming, this is the height of embankment, and opening is there, underpass is there, underpass is here. So people are shared all this information, They are shown the alignment, they are shown they are given the drawings, so that they can make their own appraisal. How my house, you see, there will be 2 kinds of effects on social effects. One is dislocation, people who will lose part or whole of their land. That is one part. The second part is, people who will not lose their land, but who will have to continue to live very near to the railway line. So during construction, there can be damage to their houses, where these trenches are to be made, or where that tunnel at a shallow depth in Thrissur has to be built, at Kozhikode has to be built, So why is all this information not shared with the people? You want to take their land, you want to take your railway line in front of their main entrance, and you don't want to show them the alignment, you don't want to show them the drawings. So this is called lack of transparency, This is why people are becoming suspicious. What is their intention? Why are they not sharing this information with us?
Related question, sir. That is, who has to give notification for the social impact assessment and the EIA, by central government or Kerala government?
You see, nobody has to give any instruction. This is a part of the planning process. When you do a feasibility study and when you prepare a plan, you have to do these studies. Okay. For doing those studies, you need permission to enter into private land. So for that, a notification has to be issued. That notification will, of course, be approval will be given by Railway Board. Railway Board will approve that yes, they have to do. We have examined their alignment. It is fine. Now they have to do social impact study and environmental impact study. So they will say ki yes, state government should issue necessary notification giving permission to people to enter houses. So it is Railway Board will give green signal that okay, do this thing, environmental impact study, do social impact study, and the state government will will carry out necessary formalities. But as I said before that, the whole alignment has to be marked on the ground, and all the survey maps have to be given to the people. It should be available on the website, so anybody can go and see where alignment is with respect to my property, what is coming there, how it is going to affect drainage, how it is going to affect the flood situation. So the communities, people and the communities as whole, can study and understand how this line is going to affect them. This is what is being done what should be done as a natural course. But it is more important in Kerala because the population is scattered everywhere. Normally for a railway line project, you don't dislocate so many houses, So many properties will be dismantled, If you look at the map on Google Earth, you can see how much of property, particularly Kottayam, places like Kottayam, then Thrissur, then even Kollam, so much of property will be destroyed, will be dismantled and taken away. So there is a lack of transparency. That transparency is not there.
One more question. That is, what are the steps in geological survey? So they collected the topsoil for soil analysis for this project. Is it part of the geological survey?
Yeah.
Is it right?
No. You see, there is something called geological. There is a body called Geological Survey of India. When I was in Trivandrum for doing this study, the first feasibility report. In fact, I had gone and visited the director of GSI at Trivandrum. He would remember that I had come to meet him. I had discussed with him and I wanted certain reports, and then so I requested him to provide me various data. So first thing is you have to contact Geological Survey of India, which is having its headquarters in regional office in Trivandrum, and I think they have got their offices in several other places. So Geological Survey of India has already done some geological survey. Geological Survey of India, so they have already done some survey, so some data you will get from there. So then you have to engage engineering geologist, there is a branch of geology called engineering geology, because geology is used for mining also, for exploration and for various activities, So the branch of geology which is dealing with the railway projects, highway project, construction projects is called engineering geology. So you have to engage engineering geologist. The engineering geologist will you will give them that this is my rough alignment. Okay, say 520 kilometer. This is what we did in Kashmir also, afterwards, when we were trying to improve the alignment. So they will divide it into 10 kilometer segments. Okay, they will walk on the whole alignment. They will take observations, photographs, and then they will study what kind of soil is there. Then using the borehole data, they have collected borehole data. Then they will do ground, various other tests, like ground penetration radar. Then there is, seismic reflection. These various techniques are there, So this team of engineering geologists, I think will take about 6 months to 1 year to give you the complete mapping of the geological conditions. Geological, geotechnical, they are both things combined. When you do geological survey, you do geotechnical also. Geotechnical becomes, more specific, like boreholes and other things, So you will need a team of engineering geologists and geotechnical experts who will walk over the whole alignment, who will use the existing reports, existing surveys done by Geological Survey of India. You will collect borehole data from other departments, from the highway department, because highway department has also done certain boreholes. They have also done certain investigations. So this whole exercise is of basically compilation of existing information and then walking over the alignment and collecting your own data. So it's a very, very, very rigorous work. It will require about 6 months to 1 year for this 520 kilometer alignment. And this is something which is they didn't do at all. They haven't done any geological survey, and geotechnical survey is only confined to certain boreholes only, no more, nothing else.
Alok Kumar Verma sir has spent more than 1.5 hours with us. I think just with one more question we'll conclude, and then after that a summary of the talk will be made in Malayalam also.
Yeah, sure. Yeah.
So the last question is, will the implementation of the automatic signaling system help in saving time? Why don't the Indian Railway allocate more money for that?
Yeah, let me tell you. Automatic signaling, you see, in normal operations, say there are between Trivandrum to Kasaragod, I think there are about 60 stations, 60, something like that, average about 10 per kilometer. One station at every 10 kilometer, that is Indian Railway average. So I guess there are about 50 to 70 stations. So each segment is about 10 kilometers. So at a time, you can have only one train in one segment, between two stations, you can have only one train. That is called absolute block system of working. But when you have automatic signaling, then you can send two trains, one behind the other. They will maintain the distance, of about 2 to 4 kilometers. So you can put more trains. So you get better capacity and your average speed also improves. So automatic signaling has two benefits. It increases the capacity of your line, and average speed will, I think, improve by about 5% or 10% by automatic signaling. But automatics, you see, when I say upgradation of the line, it includes everything, It includes signaling improvements, it includes track improvements, it includes improvement in the OHE, that electrical current which is carried by overhead on the tracks. So this, when I said 15,000 crore rupees will be required for upgrading the line, that includes everything, the signaling improvement also, and the entire thing, So automatic signaling is one component of upgradation. You will have to do the full upgradation, track plus signaling, because unless you improve the track, your speed cannot improve. Average speed will improve. By automatic signaling, average speed will improve by 5% or so, or maybe even 10%. But to have real substantial improvement, you have to upgrade the railway line so that it can carry trains even at 160 or even 180, 200 kmph. So automatic signaling is one aspect of upgradation.
So one last one, somebody has raised the hand. I think, sir, can you spend another 5 more minutes?
Yeah, sure. Why not?
Satyan has raised his hand. Satyan can unmute himself. Unmute ചെയ്തിട്ട് സംസാരിക്കുക. Hello, Satyan. Unmute ചെയ്ത് സംസാരിക്കുക. Okay, he's not seen. So thank you, sir.
You can ask him, what is the question? You can ask him.
Yeah, I asked him, he's not responding. Maybe, I don't know, maybe some problem with his network, or by mistake he has raised the hand. I do not know.
Okay.
Yeah, I think there are many more questions. I think we won't be able to take up all questions right now.
Yeah, I think now we'll go for a summary in Malayalam so that people who might have found it a little difficult in understanding in English may also be benefited. One Mr. Subhash has again raised the hand. Yes, Subhash can unmute and speak.
See, there are other questions like if technically the broader the rails, the more stable it will be. Then why are other countries going for standard gauge?
Yeah, I will tell you. You see, it is a evolutionary process. The gauge was decided not today, but 150 years ago. Okay. Why those countries went for standard gauges? Most of the European countries, they are having rocky terrain. Europe is full of mountains. You have Alps, you have Pyrenees, you have Balkans, you have Urals. So it is highly mountainous terrain. Similarly, China, almost 2/3 of China is mountainous terrain. So where there is mountainous terrain, it is rocky strata. So having standard gauge is okay because you are able to reduce cost of construction by having smaller sleepers and things like that. And I will also tell you one thing, that originally the width of coaches was not so much as it is today. Even in France, high-speed trains have width of only 2.7 meter, whereas some Japan and many other countries, Germany, they are going up to 3.3 meters. Indian is also about 3.1 meters. So standard gauge is advantageous for hilly terrain and rocky terrain because they can reduce the width of their coaches also. Okay, so the cost of tunnels reduces, the cost of viaducts and all these things reduces. You see, if you travel in India from anywhere to anywhere, you will rarely encounter any tunnels. You go from Chennai to Delhi or Mumbai to Delhi or any place, there are hardly any tunnels because our terrain is flat terrain. In India, is coastal belt or Indo-Gangetic plain in the north. We are having dominantly flat terrain with alluvium soil. Whereas Europe, Japan is highly mountainous. 90% of Japan is mountainous. So they have adopted standard gauge because it enables them to even reduce the size of trains. Okay. And a little sharper curves also, because when gauge is less, you can have little sharper curves also to negotiate this thing. You see, there's one more thing, which you can ask yourself, British government was there. India was under British rule when they decided to adopt broad gauge for the whole Indian subcontinent. Why? They could have adopted standard gauge because their home country is having a standard gauge. They will simply import everything and everything becomes easier. But they didn't, because they realized, one of the first lines they made is from Howrah to Delhi. One of the most important lines is the Howrah-Delhi line for the British Empire. And that line goes entirely through the alluvium plains of Indo-Gangetic North. So they realized, then they had to connect Mumbai with Delhi, Delhi with Chennai and all these things. They were good engineers, there's no doubt. They made, you see, the Indian railway system that we have today, 70% of it was made by Britishers in just 30 years, from 1850 to 1880 or 1890. So they were very good engineers, very practical engineers. They were innovators and leaders in railway technology. They rightly decided that for India, we should go for a broad gauge, because we are having soft alluvium soils in most of the country. We don't need tunnels. We don't need viaducts. We need embankments and cuttings in most of the country. So that is, I think, the proper reason, why India needs a broader gauge. And you see, Argentina is also a vast plain, famous for its plains, Argentina. So this is a very important factor, a broader gauge is okay for flat terrain, whereas standard gauge is preferred for, you see, in fact, Japan, I said, is 90% in mountains. Japan went for meter gauge. Till 1960, their system, 1956, their system was on meter gauge, because they wanted still smaller trains, smaller tunnels, and smaller this thing, So broad gauge is nice for flat terrain, ideal for flat terrain. I think I have, it answers.
Thank you, sir. Thank you for such an exhaustive discussion. So now I invite Dr. Babu to give a summary in Malayalam.
Thank you, George Joseph. I hope I am audible.
Yes.
Okay. Alok, Verma sir, വളരെ വിശദമായ ഒരു ചർച്ച ഇവിടെ നടത്തി. ഇത് മുഴുവൻ എനിക്ക് പറയാൻ പറ്റുമോ? സമയം എത്ര ഉണ്ടാവും എന്ന് പറയാമോ?
ഒരു 15 മിനിറ്റ് കൺക്ലൂഡ് ചെയ്യാം.
ഓക്കെ. അത് തുടങ്ങിയത് നമുക്കൊരു നല്ലൊരു ട്രാൻസ്പോർട്ട് സംവിധാനം നമുക്ക് ആവശ്യമുണ്ട്. അതേസമയം തന്നെ കേരളത്തിന്റെ ഭൂപ്രതല സ്ഥിതി, ടോപ്പോഗ്രാഫി വളരെ ചലഞ്ചിങ് ആണ്. ഇടനാട്ടിലെ കുന്നുകളാണ് അതിൽ സാർ എടുത്തു പറഞ്ഞത്. മഴക്കാലത്തൊരു എയറോപ്ലെയിനിൽ പോയി കഴിഞ്ഞാൽ വെള്ളത്തിൽ പൊങ്ങിക്കിടക്കുന്ന ദ്വീപുകളെ പോലെ തോന്നും കേരളത്തിന്റെ ഭൂമിയിലേക്ക് നോക്കിയാൽ. കാരണം ധാരാളം കുന്നുകളുണ്ട്, ബാക്കി ഭാഗം വെള്ളം നിറഞ്ഞ പാടശേഖരങ്ങളൊക്കെ ആയിരിക്കും. അതോടൊപ്പം തന്നെ വളരെയധികം പരന്നു കിടക്കുന്ന ഒരു നഗര ജനസമൂഹം, നഗര ജനവാസികൾ അല്ലെങ്കിൽ നഗരത്തിന്റെ സൗകര്യത്തിൽ ജീവിക്കുന്ന ആളുകൾ വലിയ സിറ്റികളിൽ കോൺസെൻട്രേറ്റഡ് ആണ്. 100-ലേറെ ടൗണുകളുണ്ട്. അതിൽ 50-ലേറെ ടൗണുകൾ, 50,000-ലേറെ ജനസംഖ്യ ഉള്ളത്. ഈ രൂപത്തിൽ പരന്നു കിടക്കുന്ന ഒരു ജനസംഖ്യ, നഗര ആവശ്യങ്ങളുള്ള ജനസംഖ്യ, ഇതാണ് യഥാർത്ഥത്തിൽ റോഡുണ്ടാക്കുന്നതിനും റെയിൽവേ ഉണ്ടാക്കുന്നതിനുള്ള മുമ്പിലുള്ള വലിയ വെല്ലുവിളി എന്നത്. ഇപ്പൊ NH 66 6 ലൈൻ ആക്കി മാറ്റിക്കൊണ്ടിരിക്കുകയാണ്. അതിന് മുമ്പിൽ വലിയ വെല്ലുവിളികളുണ്ട്. അപ്പോ റെയിൽ ഗതാഗതം മെച്ചപ്പെടണം. നമ്മുടെ കേരളത്തിലെ റെയിൽ ഗതാഗതം 30% വേഗത കുറവാണ് രാജ്യത്തിന്റെ മറ്റു ഭാഗങ്ങളെ അപേക്ഷിച്ച്. ആ വേഗത മെച്ചപ്പെടണം. ഇതിന് K-Rail സൊല്യൂഷൻ എന്നുള്ള ചോദ്യം അദ്ദേഹം ആദ്യം തന്നെ മുന്നോട്ട് വെച്ചു. എന്നിട്ട് K-Rail കുറിച്ച് അദ്ദേഹം ഒരു കമന്റ് പറഞ്ഞത്, അതൊരു ഇൻസ്റ്റന്റ് പ്ലാനിങ്, ഉടനടിയുള്ള ആസൂത്രണം എന്ന രീതിയിലാണ് അത് വിശേഷിപ്പിച്ചത്. ഇൻസ്റ്റന്റ് കോഫി എന്നൊക്കെ നമ്മൾ പറയുമല്ലോ, അതിനുള്ള തയ്യാറെടുപ്പുകളൊന്നും വേണ്ടാതെ ഒറ്റയടിക്ക് ഉള്ള പ്ലാനിങ്, ഇൻസ്റ്റന്റ് പ്ലാനിങ്, അതാണ് K-Rail ചെയ്തിരിക്കുന്നത്. പിന്നെ അദ്ദേഹം ഇത്തരം കാര്യങ്ങളിൽ വരുന്ന മിസ്റ്റേക്കുകളെ കുറിച്ച്, അബദ്ധങ്ങളെ കുറിച്ച് കാശ്മീർ റെയിൽവേ പ്രോജക്റ്റിന്റെ ഒരു ഉദാഹരണം കാണിച്ചു. അവര് 1999 ഒരു DPR ഉണ്ടാക്കി. എന്നിട്ട് അതിന്റെ പുറത്ത് യാതൊരു വർക്കും ചെയ്യാതെ, അതിന്റെ പഠനങ്ങളൊന്നും നടത്താതെ 2002 വർക്ക് തുടങ്ങി. അതായത് ജിയോളജിക്കൽ സ്റ്റഡി, ഭൂതലത്തിലുള്ള പഠനങ്ങളൊന്നും നടത്താതെ. എന്നിട്ട് പല മിസ്റ്റേക്കുകളും വരുത്തി. അത് അഡ്മിറ്റ് ചെയ്യാൻ തയ്യാറാവുന്നില്ല. ആദ്യം പറഞ്ഞത് ശരിയാണെന്നുള്ള വാദത്തിൽ ഉറച്ചു നിൽക്കുന്നു. ഇത് നമ്മുടെ ഗവൺമെന്റ് സംവിധാനങ്ങളുടെ ഒക്കെ ഒരു കുഴപ്പമാണെന്ന് അദ്ദേഹം പറയും. അപ്പോ KRDCL അതിന്റെ ആദ്യത്തെ പ്രൊപ്പോസൽ, അതിന്റെ നിർദ്ദേശം ഒരു ബ്രോഡ് ഗേജ് സെമി ഹൈ സ്പീഡ് റെയിൽ ലൈനിന് വേണ്ടിയാണ്. അതിന് പകല് പാസഞ്ചേഴ്സിനെയും രാത്രി ചരക്കും കൈകാര്യം ചെയ്യുന്ന ഒരു ലൈനിന് വേണ്ടി. പിന്നെ അത് മുഴുവനും തൂണുകളിലുള്ള ട്രാക്ക് എന്നുള്ള പ്രൊപ്പോസൽ മുന്നോട്ട് വെച്ചു. പക്ഷെ ഇതിനൊന്നും വേണ്ട ഹോംവർക്ക് ചെയ്തില്ല. ഈ മുഴുവൻ തൂണുകളിൽ ഉയർന്നു നിൽക്കുന്ന, തിരുവനന്തപുരം മുതൽ കാസർഗോഡ് വരെ തൂണുകളിൽ ഉയർന്നു നിൽക്കുന്ന ലൈനിന്റെ ഫീസിബിലിറ്റി സ്റ്റഡി നടത്തിയില്ല. എന്തായാലും ആ ഒരു പ്രൊപ്പോസലിന് റെയിൽവേ ബോർഡ് മുന്നോട്ട് പോകാനുള്ള തത്വത്തിലുള്ള അംഗീകാരം. ആ അംഗീകാരം വെച്ചുകൊണ്ട് ഫീസിബിലിറ്റി റിപ്പോർട്ടും DPR-ഉം തയ്യാറാക്കിയിരിക്കുകയാണ്. അപ്പൊ ആ റിപ്പോർട്ട് വന്നിരിക്കുന്ന സ്റ്റാൻഡ് അലോൺ സ്റ്റാൻഡേർഡ് ഗേജിന് വേണ്ടിയാണ്. ബ്രോഡ് ഗേജിലല്ല, സ്റ്റാൻഡേർഡ് ഗേജിലുള്ള ഒറ്റയ്ക്ക് നിൽക്കുന്ന ഒരു പാതയ്ക്ക് വേണ്ടിയാണ്. അതിന് ഒന്നാമത്തെ പ്രശ്നം, അതിന് കണക്ടിവിറ്റി ഇല്ല. ഈ ട്രാക്കിൽ നിന്നും രാജ്യത്തിന്റെ മറ്റ് ഭാഗങ്ങളിലേക്കുള്ള ബന്ധമില്ല. സെക്കൻഡ് ക്ലാസ് AC ഫെയറിനോട് ചേർന്ന ചെലവ് അതിന് വരും. അത് കേരളത്തിലെ ജനങ്ങളെ സംബന്ധിച്ചിടത്തോളം ചെലവേറിയ ഒരു യാത്രാക്കൂലി തന്നെ. പിന്നെ വലിയ തോതിലുള്ള ഭൂമി ഏറ്റെടുക്കൽ വേണ്ടി. അപ്പൊ എന്തായാലും ഒരു പ്രൈമറി ഫീസിബിലിറ്റി റിപ്പോർട്ട് ഉണ്ടാക്കിയതിന് ശേഷം ഫൈനൽ ഫീസിബിലിറ്റി റിപ്പോർട്ട് ഉണ്ടാക്കാൻ 2-3 വർഷത്തെ പഠനം വേണ്ടിവരും എന്നാണ് സാറ് പറഞ്ഞത്. അവിടെ ജിയോളജിക്കൽ പഠനം വേണം, ജിയോ ടെക്നിക്കൽ പഠനം വേണം, ഹൈഡ്രോളജിക്കൽ നീരൊഴുക്കുമായി ബന്ധപ്പെട്ട പഠനം, എൻവയോൺമെന്റൽ ഇമ്പാക്ട് സ്റ്റഡിയും സോഷ്യൽ ഇമ്പാക്ട് സ്റ്റഡിയും വേണം, പരിസ്ഥിതി ആഘാത പഠനവും സാമൂഹ്യ ആഘാത പഠനവും വേണം. പിന്നെ റൈഡർഷിപ്പ് സർവേ വേണം, യാത്രക്കാരുടെ എണ്ണത്തെ സംബന്ധിച്ച കണക്കെടുപ്പും ഈ പ്രോജക്റ്റിന്റെ കോസ്റ്റിനെ സംബന്ധിച്ച്, ചെലവിനെ സംബന്ധിച്ചുള്ള പഠനങ്ങൾ. ഈ കാര്യങ്ങളൊന്നും 45 ദിവസത്തിനുള്ളിൽ പൂർത്തിയാക്കാവുന്നതല്ല, 2-3 വർഷം എടുക്കേണ്ട പഠനങ്ങളാണ്. പക്ഷേ K-Rail ഫൈനൽ ഫീസിബിലിറ്റി സ്റ്റഡി തയ്യാറാക്കിയത് 45 ദിവസം കൊണ്ടാണ്. ഗൂഗിൾ എർത്ത് ഉപയോഗിച്ചുള്ള സർവേയിലൂടെയാണ് അത് ചെയ്തത്. അതിനൊരു 6 മാസത്തിന് ശേഷം റെയിൽവേ ബോർഡ് അംഗീകാരം കൊടുക്കുന്നു, ഡിസംബർ 2019. പിന്നീട് DPR വരുന്നു. എന്നിട്ട് ആ DPR പുറത്തുവിടാതെ സൂക്ഷിക്കുന്നു. അത് പുറത്തുവിട്ടാൽ അത് ബൗദ്ധിക സ്വത്തവകാശ നിയമത്തിന്റെ ലംഘനമാണെന്ന് പറയുന്നു. ഇപ്പൊ ചില രാഷ്ട്രീയ നേതാക്കളുടെ ഇടപെടൽ കാരണം DPR പുറത്തുവിട്ടിരിക്കുന്നു. അതില് സാമൂഹ്യ ആഘാത പഠനമില്ല, വളരെ റഫായിട്ടുള്ളൊരു പാരിസ്ഥിതിക ആഘാത പഠനമാണുള്ളത്. അദ്ദേഹം അതിന്റെ പരിമിതികളെ കുറിച്ച് പറഞ്ഞത്, ഒരു 5 കിലോമീറ്റർ ദൂരത്തിൽ ഒരു ബോർഹോൾ, ഒരു ഭൂമി കുഴിച്ചുള്ള ഒരു പഠനം നടത്തിയിട്ടുണ്ട്. യഥാർത്ഥത്തിൽ വേണ്ടത് ഭൂമിയുടെ മുഴുവൻ മാപ്പിംഗ് ആണ്. ഗ്രൗണ്ട് സർവേയിലൂടെ ഭൂപ്രതലത്തിന്റെ മാപ്പിംഗ് വേണം. എവിടെയാണ് ഗ്രൗണ്ട് ഉറച്ചിട്ടുള്ളത്, എവിടെയാണ് വീക്കായിട്ടുള്ളത്. അപ്പോ ഈ തരത്തിലുള്ള ഒരു ജിയോളജിക്കൽ സ്റ്റഡി, ഭൂതല സ്റ്റഡി പഠനം പൂർണ്ണമായും മിസ്സിംഗ് ആണ് എന്നാണ് പറയുന്നത് ഈ DPR. ജിയോ ടെക്നിക്കൽ സ്റ്റഡി എന്ന് പറയുമ്പോൾ ബോർഹോൾ ഇട്ടുകൊണ്ട് ഭൂമിയുടെ അടിയിലേക്കുള്ള സ്ഥിതി പരിശോധന ആയിരിക്കണം. അത് വളരെ അപര്യാപ്തമായ രീതിയിൽ നടത്തിയിരിക്കുന്നു എന്നാണ് പറഞ്ഞത്. സാർ ഒരു 20 ലൊക്കേഷൻസിന്റെ കാര്യങ്ങൾ ചെക്ക് ചെയ്തിട്ട് അത് ഈ ജിയോളജിക്കൽ സ്റ്റഡി, ജിയോ ടെക്നിക്കൽ സ്റ്റഡിയിൽ അലൈൻമെന്റ് കൊടുത്തിട്ടില്ല. അപ്പോൾ അലൈൻമെന്റ് വഴി നേരിട്ട് ചെക്ക് ചെയ്യാൻ കഴിയില്ല. സാർ അതിന്റെ ലൊക്കേഷൻ എടുത്ത് കോർഡിനേറ്റ്സ് എടുത്തുകൊണ്ട് അലൈൻമെന്റിൽ ചെക്ക് ചെയ്തു. അപ്പൊ 20 ലൊക്കേഷനിൽ ചെക്ക് ചെയ്തപ്പോൾ 16 ബോർഹോളുകൾ ഇട്ടിരിക്കുന്നത് നിലവിൽ അവർ പറഞ്ഞിരിക്കുന്ന അലൈൻമെന്റിൽ 100 മീറ്ററും 1 കിലോമീറ്റർ വരെ ദൂരെ മാറിയുള്ള ഒരു സ്ഥലത്താണ്. അതുകൊണ്ട് ഈ അലൈൻമെന്റിൽ ട്രാക്ക് ഉണ്ടാക്കാൻ എന്ത് ഗുണം ഉണ്ടാവും? ഇനി ബാക്കിയുള്ളൊരു 4 എണ്ണം 50 മീറ്ററിന് ഉള്ളിൽ വരുന്നു. പക്ഷെ അത് പലതും റോഡിലാണ്. നിലവിലുള്ള റോഡ് നിർമ്മാണം കൊണ്ടും കൺസ്ട്രക്ഷൻ കൊണ്ടും ഒക്കെ ഭൂമി ഉറച്ചതായിരിക്കും. ആ പഠനം കൊണ്ട് കുറച്ച് ഉള്ളിലോട്ട് മാറിയുള്ള സ്ഥലത്ത് റെയിൽവേ ട്രാക്ക് ഇടാനുള്ള വിവരം നമുക്ക് കിട്ടില്ല. അപ്പൊ ഇത് കംപ്ലീറ്റ് ആയിട്ട് ഒരു കൃത്രിമ റിപ്പോർട്ടാണ്. കാര്യങ്ങൾ വെറുതെ ചേർത്ത് വെച്ചിരിക്കുകയാണ്, ഒരു പഠനമല്ല എന്നുള്ളതാണ് അദ്ദേഹം പറയുന്നത്. അപ്പൊ എന്തുകൊണ്ട് ഇങ്ങനെ സംഭവിച്ചു എന്നുള്ള ചോദ്യത്തിലേക്ക് വരുന്നു. അദ്ദേഹം പറയുന്നു, ഈ ട്രാൻസ്പോർട്ടേഷൻ വ്യവസായം, ഗതാഗത വ്യവസായം എന്ന് പറയുന്നത് ദിനം പ്രതി വികസിച്ചുകൊണ്ടേയിരിക്കുകയാണ്. അപ്പോൾ വികസിത രാജ്യങ്ങളിലുള്ളത് പകർത്താൻ നമ്മുടെ നാട്ടിലേക്ക് കൊണ്ടുവരാനുള്ള പ്രവണത എപ്പോഴും ഉണ്ട്. 1950 വരെ ട്രാൻസ്പോർട്ടേഷൻ കാര്യത്തിൽ റെയിൽവേ ആയിരുന്നു കൂടുതൽ കാര്യങ്ങൾ നിർവഹിച്ചത്. പിന്നീട് എയർപ്ലെയിൻ വന്നു, കാറുകൾ വളരെ സാധാരണമായി, ജംബോ ജെറ്റുകളും അതുപോലെ എയർ ട്രാവല് സാധാരണക്കാർക്ക് പലർക്കും മിഡിൽ ക്ലാസ്സിനൊക്കെ അഫോർഡ് ചെയ്യാവുന്ന രീതിയിലേക്ക് വന്നു. ഫ്ലൈറ്റ് ചാർജ് കുറഞ്ഞു. മിഡിൽ ക്ലാസ്സിൽ വലിയൊരു ശതമാനത്തിന് കാർ ഓണേഴ്സ്, റോഡ് ഗതാഗതം വലിയ പ്രാധാന്യത്തോടു കൂടി. ഈ ഒരു മാറ്റത്തിനനുസരിച്ച് റെയിൽവേ അപ്ഗ്രേഡ് ചെയ്ത് ഏറി വരുന്ന ഗതാഗത ആവശ്യങ്ങളെ തൃപ്തിപ്പെടുത്താൻ അപ്ഗ്രേഡ് ചെയ്യേണ്ടതായി. നമുക്ക് 1966 മുതൽ 75 വരെ അതിനിടയിൽ രാജധാനി ട്രെയിൻ ഉണ്ടായിരുന്നു. അതിന് 130 കിലോമീറ്റർ സ്പീഡ് ഉണ്ടായിരുന്നു എന്നാണ് പറഞ്ഞത്. 75 വരെ റെയിൽവേ ഈ ഗതാഗത രംഗത്തുള്ള മറ്റ് മേഖലകളിലെ എയർപ്ലെയിന്റെയും റോഡ് ഗതാഗതത്തിന്റെയും വികാസത്തിനൊപ്പിച്ച് മുന്നോട്ട് വന്നു. പക്ഷേ അതിനുശേഷം 95 ശേഷം റെയിൽവേ ബോർഡ് ഉറക്കത്തിലായി എന്നാണ് സാർ പറഞ്ഞത്. അപ്പൊ റോഡിന്റെയും എയർപ്ലെയിന്റെയും മത്സരത്തിന് അനുപാതികമായി റെയിൽവേ രംഗത്ത് ഒരു അപ്ഗ്രഡേഷൻ, ഒരു നവീകരണം ഉണ്ടായി. അതിനുശേഷം അവരിപ്പോ ആ ഉറക്കത്തിൽ നിന്ന് ഉണർന്നിട്ട് വരുന്ന ഹൈസ്പീഡ് പ്രോജക്റ്റുകൾക്കൊക്കെ അപ്രൂവൽ കൊടുത്തുകൊണ്ടിരിക്കുക. അതുകൊണ്ടാണ് സ്റ്റാൻഡേർഡ് ഗേജിന് അവർ അപ്രൂവൽ കൊടുത്തിരിക്കുന്നത്. സ്റ്റാൻഡേർഡ് ഗേജ് എന്ന് പറഞ്ഞാൽ ബ്രിട്ടനിലുണ്ടായ 1860 ഉണ്ടായ ഗേജാണ്. 4 അടി 8.5 ഇഞ്ച് എന്ന് പറഞ്ഞു. ഇന്ത്യയിലുള്ളത് ബ്രോഡ് ഗേജ് ആണ്. ഇന്ത്യയിൽ മാത്രമല്ല ബ്രോഡ് ഗേജ് ഉള്ളത്, ഐബീരിയൻ പെനിൻസുല, സ്പെയിൻ ആൻഡ് പോർച്ചുഗൽ ബ്രോഡ് ഗേജ് ആണ്. അർജന്റീനയിൽ ബ്രോഡ് ഗേജ് ആണ്. മുൻ സോവിയറ്റ് യൂണിയനിലെ രാജ്യങ്ങളിൽ റഷ്യയിൽ ഉൾപ്പെടെ ബ്രോഡ് ഗേജ് ആണ്. അപ്പോ ഈ വാഗണിന്റെ വലിപ്പവും മറ്റു കാര്യങ്ങളും ഒക്കെ ശരി ഒന്നായിരിക്കുമ്പോൾ തന്നെ ട്രാക്കിന്റെ ഉള്ളിലുള്ള വീതിയാണ് ഈ ഗേജ് ആയിട്ട് അറിയപ്പെടുന്നത്. ഇന്ത്യയിൽ വളരെ പരന്ന സമതല ഭൂപ്രകൃതിയാണ്. അതുപോലെ പിന്നെ നദികളുടെ മണ്ണടിഞ്ഞിട്ടുള്ള പിന്നെ ഭൂപ്രകൃതിയാണ്. അലൂവിയൽ സോയിൽ എന്ന് പറയുന്നത് പിന്നെ ഫ്ലഡിങ്ങിലൂടെ ഉണ്ടാവുന്ന തരിമണ്ണടിഞ്ഞ സോയിൽ മണ്ണിന്റെ പ്രകൃതിയാണെന്ന് ഞാൻ കരുതുന്നു. അപ്പൊ അതുകൊണ്ട് ഇവിടെ ബ്രോഡ് ഗേജ് ആണ് ശരിയായ ഗേജ് എന്ന് അദ്ദേഹം പറയുന്നത്. കാരണം അതിന് കൂടുതൽ ഏരിയ കവർ ചെയ്യാൻ പറ്റും. ആ പാളങ്ങളുടെ ഇടയിലുള്ള ദൂരം കൂടുതലായിട്ട് കൂടുതൽ ഏരിയയിലേക്ക് വെയിറ്റ് ഡിസ്ട്രിബ്യൂട്ട് ചെയ്ത് പോകും. അത് സ്റ്റാൻഡേർഡ് ഗേജിനേക്കാൾ 18% അതിന് വീതി കൂടുതലാണ്. അപ്പൊ അങ്ങനെയൊക്കെ ഇരിക്കുമ്പോൾ എന്തുകൊണ്ട് സ്റ്റാൻഡേർഡ് ഗേജ് അപ്രൂവ് ചെയ്യപ്പെട്ടു? ഒന്നാമത് രാഷ്ട്രീയക്കാർ ഇതിനെക്കുറിച്ച് വെൽ ഇൻഫോംഡ് അല്ല. അവർക്ക് അവരുടെ പേരിൽ ഒരു പ്രോജക്റ്റ് വരാൻ താല്പര്യമുണ്ട്. ഉദ്യോഗസ്ഥർ പറയുന്നത് അവര് അങ്ങ് അപ്രൂവ് ചെയ്യുന്നു. ഇപ്പോഴാകട്ടെ ജനങ്ങൾ അതിനെ ചോദ്യം ചെയ്യാൻ തുടങ്ങിയിരിക്കും. എന്തായാലും ഈ ചർച്ചയും ജനങ്ങളുടെ ചോദ്യം ചെയ്യലും നല്ലതാണ്. അങ്ങനെ ഒരു പൊതുജനാഭിപ്രായം ഉയർന്നു വരുന്നത് കേരളത്തിന് മാത്രമല്ല ഇന്ത്യക്ക് തന്നെ നന്നാവും. ഈ കാര്യങ്ങൾ ജനങ്ങൾ അഭിപ്രായം പറയുന്നത് ശരിയും തെറ്റും തിരിച്ചറിയും. അപ്പോൾ സാറ് പറഞ്ഞ സ്റ്റാൻഡേർഡ് ഗേജ് തള്ളിക്കളയാം, അത് ഇന്ത്യക്ക് യോജിച്ചതല്ല എന്ന് സാർ പറയുന്നു. പിന്നെ ഉദാഹരണമായിട്ട് പൂനെ നാസിക് ബ്രോഡ് ഗേജ് ലൈനാണ്. അത് 250 കിലോമീറ്റർ സ്പീഡ് വരെ അച്ചീവ് ചെയ്യാവുന്ന ആ ലൈനിന് റെയിൽവേ ബോർഡ് അപ്രൂവൽ കൊടുത്തിട്ടുണ്ട്, അംഗീകാരം കൊടുത്തിട്ടുണ്ട്. അപ്പൊ അങ്ങനെ ഇരിക്കുമ്പോൾ സ്റ്റാൻഡേർഡ് ഗേജിൽ മാത്രമേ ഈ സ്പീഡ് അച്ചീവ് ചെയ്യാൻ കഴിയൂ എന്ന് K-Railന്റെ ഓഫീസർമാരും തെറ്റിദ്ധാരണ പരത്തുകയാണ്. 160 കിലോമീറ്റർ മുകളിൽ സ്പീഡ് ബ്രോഡ് ഗേജിൽ അച്ചീവ് ചെയ്യാൻ കഴിയില്ല എന്നവർ പറയുന്നത് പച്ച നുണയാണ്. പൂനെ നാസിക് ബ്രോഡ് ഗേജ് ലൈൻ ഇന്ത്യൻ റെയിൽവേ തന്നെ അംഗീകാരം കൊടുത്തിരിക്കുന്നു 250 കിലോമീറ്റർ വരെ സ്പീഡ് അച്ചീവ് ചെയ്യാവുന്ന തരത്തിൽ. പിന്നെ അദ്ദേഹം K-Railന്റെ അലൈൻമെന്റിനെ വിളിക്കുന്ന ഒരു റോളർ കോസ്റ്റർ അലൈൻമെന്റ് എന്ന് വെച്ചാൽ വളരെയധികം കയറ്റിറക്കങ്ങളും വളവ് തിരിവുകളും ഉള്ള ഒരു പാതയാണ്. അത് അങ്ങനെ സംഭവിക്കാൻ കാരണം ഗൂഗിൾ എർത്തിലൂടെ അതിന്റെ സഹായത്തോടു കൂടി അലൈൻമെന്റ് ഉണ്ടാക്കി. എന്നിട്ട് DPR ഉണ്ടാക്കിയപ്പോൾ പല അഡ്ജസ്റ്റ്മെന്റുകളും ചെയ്യേണ്ടി. നിലവിൽ ഗൂഗിൾ എർത്തിൽ കണ്ട് വരച്ചു വെച്ചിരുന്ന അലൈൻമെന്റിന് പല മാറ്റങ്ങളും വരുത്തിയിട്ടുണ്ട്. അപ്പോൾ ഇടത്തോട്ടും വലത്തോട്ടും മുകളിലേക്കും താഴേക്കും ഒക്കെയുള്ള വളവ് അലൈൻമെന്റ് വരുത്തേണ്ടി വന്നു. എന്നിട്ട് അദ്ദേഹം പറയുന്നു, തിരശ്ചീനമായ തരത്തിൽ ഇടത്തോട്ടും വലത്തോട്ടുമുള്ള വളവുകൾ നിലവിലുള്ള ബ്രോഡ് ഗേജ് പാതയേക്കാൾ എണ്ണത്തിൽ കൂടുതലുണ്ട്. അതുപോലെ മുകളിലേക്കും താഴേക്കുമുള്ള കയറ്റിറക്കങ്ങളും ധാരാളമുണ്ട്. അപ്പൊ ഇത് മെയിൻ്റനൻസിന് പ്രശ്നമുണ്ടാവും. പാരസൈറ്റിക് മൂവ്മെന്റ്സ്, ധാരാളം അനാവശ്യമായ ചലനങ്ങൾ വരും. അതുകൊണ്ട് തന്നെ തേയ്മാനവും മെയിൻ്റനൻസും കൂടും. ഈ ലൈനിന്റെ സ്റ്റെബിലിറ്റിയെ തന്നെ അത് ബാധിക്കാം. ചിലപ്പോൾ ട്രെയിൻ മറിയുക വരെ ചെയ്യാമെന്ന് അദ്ദേഹം മുൻകൂട്ടി കാണും. അപ്പൊ അദ്ദേഹം പറയുന്നു, ഈ പ്രശ്നത്തിന് റോളർ കോസ്റ്റർ അലൈൻമെന്റ് എന്ന് വിളിക്കുന്ന ആ വളഞ്ഞു പൊളഞ്ഞുള്ള അലൈൻമെന്റ് ഒരു രാജ്യത്തിന്റെ ഭൂപ്രകൃതി കാരണം വേണ്ടി വന്നാൽ അത് പരിഹരിച്ച ഒരു നാടാണ് ഫ്രാൻസ്. അവിടെ അലൈൻമെന്റ് വന്നപ്പോൾ ഇങ്ങനെ ഉണ്ടായി, ധാരാളം വളവ് തിരിവുകളുള്ളത്. അതിനെ കാരണം ഫ്രാൻസിന്റെ ഭൂപ്രകൃതിയും വളരെയധികം കയറ്റിറക്കങ്ങളുള്ളതാണ്, കുന്നുകളും കുഴികളും ഉള്ളതാണ്. ഫ്രാൻസ് അതിനൊരു മാർഗം കണ്ടുപിടിച്ചിട്ടുണ്ട് എന്ന് അദ്ദേഹം പറയുന്നു. അത് സസ്പെൻഷനിലൂടെ ആണ് എന്ന് അദ്ദേഹം സൂചിപ്പിച്ചു, അതിന്റെ വിശദാംശം പറഞ്ഞില്ല. എന്തായാലും പിന്നെ അത് ഫ്രാൻസിൽ നിന്ന് പഠിക്കാനുണ്ട് എന്ന് അദ്ദേഹം സൂചിപ്പിച്ചു. K-Rail ഉണ്ടാക്കി വെച്ചിരിക്കുന്ന അലൈൻമെന്റ് ഇൻവാലിഡ് ആണ്, അത് സാധുവല്ല എന്നാണ് അദ്ദേഹം പറഞ്ഞത്. ഇനി എന്താണ് പകരം ബദൽ എന്താണ്? അദ്ദേഹം പറയുന്നു, നിലവിലുള്ള ലൈൻ നവീകരിച്ചാൽ 160 മുതൽ 200 കിലോമീറ്റർ സ്പീഡ് വരെ എത്താൻ കഴിയും. അത് പല നാടുകളും അത് ഘട്ടം ഘട്ടമായിട്ടാണ് ചെയ്തത്. ചൈന 1997 മുതൽ 2012 വരെ അവരുടെ പ്രധാന ലൈനുകളെല്ലാം അപ്ഗ്രേഡ് ചെയ്തു. അത് 6 ഘട്ടങ്ങളിലായിട്ടാണ് അവർ ചെയ്തത്. 160-200 സ്പീഡ് വരെ ആക്കി. അപ്പോ ഇന്ത്യയിലും അങ്ങനെ ചെയ്യാൻ കഴിയുമെന്നാണ് അദ്ദേഹം പറയുന്നത്. ഈ നിലവിലുള്ള ലൈനിന് 1 ഡിഗ്രി ചെരിവ് വരുന്ന വളവുകൾ കുറച്ചുണ്ട്, അത് സാരമില്ല. അവിടെ 190 കിലോമീറ്റർ വരെ സ്പീഡ് അച്ചീവ് ചെയ്യാൻ കഴിയും. 2-3 ഡിഗ്രി ചെരിവ് വരുന്ന വളവുകളുണ്ട്, അത് ചിലപ്പോൾ നിവർത്തേണ്ടി വരും. അപ്പൊ ഇതൊക്കെ നിലവിലുള്ള ലൈനിനെ നവീകരിക്കുക എന്നുള്ളത് സാധ്യമാണെന്നുള്ളതിന്റെ കാര്യമായിട്ടാണ് ഇത് പറഞ്ഞത്. അപ്പൊ ഒരു 15,000 കോടി രൂപ ചെലവാക്കുകയാണെങ്കിൽ അദ്ദേഹത്തിന്റെ കണക്ക് പ്രകാരം ഈ നിലവിലുള്ള ലൈൻ നവീകരിക്കാൻ കഴിയും. ഒരു 3-4 വർഷത്തെ പണി എടുത്തുകൊണ്ട് തിരുവനന്തപുരം മുതൽ കാസർഗോഡ് വരെ 5 മണിക്കൂറിനകം എത്തിച്ചേരുന്ന ടിൽറ്റിംഗ് ട്രെയിൻ എന്ന് പറഞ്ഞാൽ അദ്ദേഹം പിന്നീട് വിശദീകരിക്കുന്നുണ്ട്. അത് ഉൾപ്പെടെ ഇമ്പോർട്ട് ചെയ്യേണ്ടി വന്നാൽ അത് ചെയ്തുകൊണ്ട് ഈ 15,000 കോടി രൂപ ചെലവിൽ സ്പീഡ് വർദ്ധിപ്പിക്കാൻ കഴിയും. 160 മുതൽ 200 കിലോമീറ്റർ വരെ സ്പീഡ് നിലവിലുള്ള ട്രാക്കിൽ അച്ചീവ് ചെയ്യാൻ കഴിയുമെന്ന് അദ്ദേഹം പറഞ്ഞു. അതിന് വേണ്ടി വരുന്ന ഭൂമി ആവശ്യം നിലവിൽ 1300 ഹെക്ടർ ഏറ്റെടുക്കുന്നതിന്റെ സ്ഥാനത്ത് അതിന്റെ K-Rail ഏറ്റെടുക്കാൻ ഉദ്ദേശിക്കുന്നതിന്റെ സ്ഥാനത്ത് 10% ഭൂമി ഏറ്റെടുത്തുകൊണ്ട് ഇത് ചെയ്യാൻ കഴിയും. അങ്ങനെ സ്റ്റേഷനുകളുടെ തിരക്ക് കുറയ്ക്കാനും നിലവിലുള്ള ചില വളവുകൾ നിവർത്തി റിയലൈൻമെന്റ് വരുമ്പോൾ ആ ഭൂമിയെ മോചിപ്പിച്ച് അത് മറ്റു കാര്യങ്ങൾക്ക് ഉപയോഗിക്കാനും ഒക്കെ സാധിക്കുമെന്ന് അദ്ദേഹം പറയും. അതാണ് ഏറ്റവും ചെലവ് കുറഞ്ഞ, ഏറ്റവും യുക്തിയധിഷ്ഠിതമായ, ഏറ്റവും സൗകര്യപ്രദമായ പരിഹാരം. ഇങ്ങനെ ചെയ്യുകയാണെങ്കിൽ റെയിൽവേ ബോർഡ് അതിന്റെ കോസ്റ്റ് മുഴുവൻ വഹിക്കുകയും ചെയ്യും. ഒരുപക്ഷെ നമുക്ക് പ്രയോറിറ്റി കിട്ടുന്നില്ല എന്നുണ്ടെങ്കിൽ മറ്റ് ട്രാക്കുകൾ റെയിൽവേ അതിന് പ്രയോറിറ്റി കൊടുക്കുകയാണെങ്കിൽ നമ്മളൊരു 10% അതിന്റെ കോസ്റ്റ് വഹിക്കാമെന്ന് പറഞ്ഞാൽ നമ്മുടെ ഈ ട്രാക്ക് പ്രയോറിറ്റി അടിസ്ഥാനത്തിൽ റെയിൽവേ കൂടി ചെയ്യുകയും ചെയ്യും. പക്ഷെ നിലവിൽ വേറൊരു പുതിയ ട്രാക്ക് സെമി ഹൈ സ്പീഡിന് വേണ്ടി ഉണ്ടാക്കുന്നത് പൂർണ്ണമായും ഉപേക്ഷിക്കണമെന്നല്ല പറയുന്നത്. പക്ഷെ ഏറ്റവും എളുപ്പത്തിലുള്ള ഒരു പരിഹാരം, ഏറ്റവും ചെലവ് കുറഞ്ഞ പരിഹാരം ഇതാണ്. പിന്നെ ദീർഘകാല അടിസ്ഥാനത്തിൽ ഒരു ന്യൂ ലൈൻ, പുതിയൊരു ലൈനിനെ കുറിച്ച് ആലോചിക്കുകയും ചെയ്യാം. അതിന് കേരളത്തിന് കോസ്റ്റ് ഷെയർ ചെയ്യുകയും ചെയ്യാം. പക്ഷെ ഇത്ര വളരെ വേഗത്തിൽ ഇൻസ്റ്റന്റ് പ്ലാനിങ്ങിലൂടെ അല്ല ഉണ്ടാക്കേണ്ടത് എന്നുള്ളതാണ് അദ്ദേഹത്തിന്റെ തുടക്കത്തിലെ പോയിന്റ്. പിന്നെ കുറെ ചോദ്യങ്ങൾ വരികയുണ്ടായി. അതുകൂടി ഉൾപ്പെടുത്തണുണ്ടോ?
അത് വേണമെന്നില്ല.
ആ, ഓക്കെ. അപ്പൊ ദാറ്റ്സ് ഓൾ.
So thank you, sir, for spending more than 2 hours with us and having a very exhaustive discussion. I think most of the issues have been clarified. I think the people will get more clarification on this, and the affected people also will get some confidence. And so I thank you very much for this very educative discussion and talk. Thank all of you for your patient listening. So we'll conclude here.
Sir, your microphone is muted. Please unmute.
Yeah, I would also like to thank the organizers for inviting me to speak, and for so many people to patiently sit through it and hear some of what may have looked like quite technical, though I have tried to explain it in as simple words as possible. I hope I have succeeded, and I hope that you enjoyed listening to me. If you want any further information, you can go to my Twitter handle, Trains Are Best, @TrainsAreBest. That is my Twitter account. And I'm also going to start my website also, maybe within 1 or 2 weeks. So you can go to my website also, which is also called trainsarebest.com. So thank you. Thank you once again.
Okay, thank you, sir.
Thank you very much, sir.